Okay, now we get to do applications using linear inequalities. So the stuff we learned in section 1, we're going to use to solve it, but now you need to learn how to set it up. Okay, so, or from the paragraph, right? And this table has some of the phrases that you're going to run into a lot. Um, less than and more than we cover, right? So this is a less than symbol, this is a more than. However, these kind of get a little confusing sometimes. If it's at least, it's going to be greater than, but it can equal it as well. So like if you have at least $20, you can have $20 or more, right? So 20 would be fine. That's why it's a greater than or equal to. If you have at most $20, then 20 is the highest you get, but it could be lower. Okay, so the same thing if you have a minimum of 20, it can equal 20. It can be 20. That's why it's equal to, greater than or equal to. No more than 20 means you have 20. You could have 20, but you can't have more than that, so it's going to be a less than or equal to. Okay, so just think logically and in real life type terms which phrase you're going to need or which symbol you're going to need for your phrase, right? And we'll go over that as we see these. First type we get is translation again. And so you're going to have something that you just need to read through and just translate. So the difference is instead of having just an equal sign, it's going to have an inequality sign someplace. Okay? Difference between 4 times a number and the number is greater than 10. Okay? So that's replacing the equal sign. So we do exactly the same thing that we did before. So difference is the special name for subtract, and we're looking for the and, which is right there. So that's where the subtract is going to go. We're going to subtract 4 times a number and the number, and it's greater than 10. Okay, like terms. 4n minus n is 3n is greater than 10. Divide both sides by 3, and we get, whoops, not equal anymore. Okay, so the number that when you do 4 times it minus it has to be greater than 10 is 10 thirds. Okay, let's check it and see. So we're going to do 4 times n minus n, and we need it to be greater than 10. Okay, so 4 over 1 gives you 40 thirds when you times it by 10 thirds. Minus 10 thirds is 30 thirds, which is 10. So now when you're checking, okay, is 10 greater than 10? No, it's not. Okay, so you're checking an equal. Okay, I know that seems really weird because you're solving the equation as we did before, although it has a new symbol in the middle instead of the equal. So when you're checking it, these two still have to be the same. Okay, this represents on a number line right here every number starting at 10 thirds, open circle, and going to the right. So every number not including 10 thirds, but above 10 thirds. Okay, 10 thirds is equal to 3 and 1/3. So let's try 5. Okay, so I'm going to put 5 in. So 4 times 5 minus 5, is that greater than 10? We get 20 minus 5 is 15. 15 is greater than 10. Yep. Okay. 10 thirds is that lower limit, if you will, of this arrow. So when I plug it in, that would be equal right here. Okay, so that gives you your limit, but we know instead of being equal, we have to be open circle or not equal. Okay, next type of problem. So commission is using percents from the last chapter. So Marla's job provides a yearly base salary of $25,000 plus a commission of 7% of her sales. If her goal is to earn a yearly income of at least $39,000, what will her total sales need to be to achieve that goal? Okay, so at least right there. So it can be $39 and she wants more than that. So 39,000 is the lowest she possibly wants, and anything above that would be better, right? Okay, so let's set up the rest of this. Yearly base salary of $25,000. So she starts with the 25,000 no matter what. And we're going to add on to that. That's why it says plus a commission of 7% of her sales. Of, in this case, is multiply. Okay? And when you see a percent in a problem, you have to convert it to either a decimal or a fraction to put it into the equation to work with. Okay, I'm assuming most of you are going to do decimals because you use calculators, right? Okay, so 7% as a decimal, you're going to move the decimal back 2 places. So 7, 0, and then the decimal goes right there. I always put a 0 in the front or my decimal sometimes drops. So that now goes into the formula. And I'm going to say N for the number of dollars, D for dollars, S for sales, doesn't matter. Okay, so that's how much her sales are, is N. Okay, if her goal is to earn a yearly amount of blah, 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 then wants to be at least 39,000. Okay, there's my inequality. I need to solve that, and here we go. So I'm going to subtract the extras, which are in the front this time. And we get 0.07n greater than or equal to 14,000. Now divide by the coefficient, so 0.07. And we get n is greater than, calculator time, 200,000. Okay, since what does her total sales need to be? That's going to be money. So dollar sign. So if she sells at least $200,000 with her $25,000 base salary and 7% of what she sold, she will make the $39,000 that she wanted. Okay? The more she sells over the $200,000, the more she earns over the $39,000. Okay, car rentals. Leslie wants to rent a car for a day. The rental company charges a daily rate of $18.95 plus 19 cents for each mile driven. If Leslie only has $50 to spend on the car rental, what is the maximum number of miles she can drive? Round the answer to the nearest mile. Okay, I don't think rental companies do it this way anymore, but we're going to do the problem anyway. All right, so what is the maximum number of miles she can drive? Okay, so that means, okay, if she drives 0 miles, 10, 20, 30, etc., somewhere up here, there's going to be a number of miles that represents the maximum number she can drive so that this earns, or it makes it so that she has to pay $50. Okay. Above that would be $51, and that's not enough. She only or too much. She has $50 to spend, and that's it. So we want to figure out how many miles she can go so that it evens out to 50 exactly. And then we can say that anything less than that will work. We don't want anything more than that. It can be anything less than that. Less than or equal to that, right? Okay, let's set it up. All right, so they charge a daily rate of $18.95. So we're going to start with that and then add 19 cents for each mile. Okay, so the daily rate here, the $18.95, everyone pays. And we're going to add on to that 19 cents per mile. Okay, now this is in dollars, this is in cents. You can't combine them like that. So this is $18.95, right? So we're going to write this as 19 cents like that, and then it's in the same format as the first one. Okay, for each mile driven. So that's going to be right here, 19 cents for each mile. So it's going to be 0.19 times the number of miles. Okay, now if she has only $50 to spend, this needs to be less than or equal to the 50. Can't go over, right? Okay, let's solve this. And then there's one little thing at the end that I need to show you. So subtract the extras, which in this case is again in the front, $18.95. Okay, I know you're doing this on your calculators most likely, but just make certain that you are showing enough work so that you can, sorry about that, get full credit. Okay, so like right here, you're going to do the 50 minus the 18.95 on your calculator, which is perfect, but write it down before you divide. Okay, write down the original step, the next step, the next step. You don't have to do this one. That's a little bit extra, but you do have to do the next. So this one, you don't have to show this. However, I would if you're not really comfortable. So now n is less than or equal to, so now calculator, divide by 19 cents, and we get 163.42105, and a whole bunch of other things. Okay, so basically, this is the number of miles we can drive that make it exactly 50. Okay, now here's what I wanted to point out. It says round the answer to the nearest mile. I don't agree, and this is why. Okay, if I rounded it to the nearest mile every time, no matter what, this is going to round down, and that would be okay. But what if this were an 8 instead? That would have to round up. And if I rounded up, I would be above the $50. I'd need some extra money. Okay, so on this particular one, I'm going to watch in the future for the phrasing. I will say something like round to the dollar amount that makes sense or something like that, because you can't go over. This one doesn't, because when we're rounding to the nearest dollar, the 4 doesn't do anything to the 3 and it just leaves it. Okay, so 163, whoops, not dollars, right? Miles driven. So Leslie can drive 163 miles at 19 cents a mile, and it'll still be under $50. Okay, so let's check it just so I can show you. 163, put it in here for n, and this is what we get. Okay, once you do the computation, that's what you get. So she would spend $49.92, which is as close as you can get to 15 or $50 without going over, if each mile is 19 cents. If I add 19 cents onto that, I'm going to be at $50.11, which she doesn't have. Okay? So make certain you round it so that it makes sense. And there's another one of those types of problems coming up so you can see how to round it. But for right now, we're going to do a second part of this car rental problem. Okay, so here we go. Leslie found a second rental company that charges 75 cents per mile with no additional fee. So how many miles can she drive so that the second rental company costs less than the first? Answer in full miles, no decimals. Okay, so this is what she's looking for. She wants the second rental company costs less than the first. Okay, so the first one is what we did on the last page. So this 18.95 plus 19 cents times n. Okay, so 18.95 plus 19 cents times n is that side. Now the second side is what we have right here, 75 cents per mile with no additional fee. So this is 75 cents times the number of miles. So now we have a new inequality to solve. Okay, let's get the variable over on one side. So it cancels over here. And we get 0.56 n is less than 18.95. Now, okay, now we want to divide by 0.56, the coefficient, right? And we get n is less than 33.839285, whole bunch of others. Okay, it says answer in full miles, no decimals. Okay, which is what I was bringing up in that first page. If I round this full miles, that 8 would move the 3 up, right? So it would be 34 miles. Okay, let's check and see. Okay, that becomes the check inequality. Putting 34 in here for n and here for n. This is what we get. On the left, we get 25.5. And now, is that less than the right? Okay, so 1895 plus 6.46. So, calculator time, we get 25.41, which is false. Okay, the reason it's false is because we had to round. If I would have used this exact number in here and here, it would have been fine. But when I rounded this up, it made it so our mileage went over. Okay, so instead of rounding it up, just take the whole number. Okay, if I were to put a 33 down here instead of 34, okay, let me slide it up just a little bit and we'll work that one out. You can see. Okay, so redoing it with the 33 gives us 24.75 is less than 18.95 plus 627. So 2475 is less than 2522. Okay, so in real life problems with inequalities, rounding sometimes messes up because that decimal portion makes a difference. Okay, so just quickly check whether you want to round it to the number as is or round it however it tells you. This one should have rounded up and it should have been 34, but 34 didn't work. Okay, 33 did. So 33 miles is the answer. There are other types of problems that have that same situation happen, and I'll show you those when we get to them. I'll bring it up for certain. But for right now, let's try the next type. So averaging. This is something you might want to try in real life with this class or another class or something. It's kind of helpful. Okay, so one student has scores of 85, 65, and 82 on his first three tests. He needs an average of at least 80 to earn a grade of a B minus in the class. So what's the minimum score that the student needs on the fourth test to ensure a grade of a B minus? Okay, and then this reminder up here is how to find an average. But this is something that you could see that you could possibly use, right? You're going to have 4 exams, but you only have 3. What do you need to get on the fourth to get the grade that you want? This is awesome. Okay, average. To find the average, you add all of the numbers together and then divide by the number of numbers you added. Okay, so if I were to find the average of these 3, I would just add all 3 of them and divide by 3. Okay, that will give you your current average. It won't help with the fourth exam, but this will give you your current average. Okay, so let's work it into the fourth exam as well. And the way you do that, if you're finding the average of 4 exams, you're going to want to divide by 4, and you're going to have 1, 2, 3, 4 scores in there. So 85, 65, 82, and whatever you're going to get on the next one. Okay, so you need to figure out 4 things to divide by because you're going to have 4 exams. So the way we set this up algebraically, 85 plus 65 plus 82 plus your score on the last exam divided by 4. And now you want it to be at least 80. So 80 is the lowest you can get, but then it can go up, right? Okay, so we're going to use greater than or equal to 80. 80 is okay, but bigger is better. Okay, to do this particular one now, I'm going to add these 3 up, and I get 200, whoops, can't write with a little red dot, 232 add x divided by 4 is greater than or equal to 80. Okay, opposite of divide by 4, right here, I want to get rid of the fraction, is times by 4. Okay, so I'm going to times both sides by 4, cancels this, and we get 232 add x is greater than or equal to 320. Get the variable by itself, so we're going to subtract 232 from both sides. Let's write it correctly. There we go, 232. Okay, so this is group work because I used to do it in class, but you're going to do these at home and see how you do on your own. So pause it. You have this one and those 2 plus this last one, and we're done. Okay, so try all four of these on your own, set them up, solve them, double check your answer, and then come back and see how you did compared to what I'm going to show you. All right, so sum is the name for add. It needs an and that's where the add is going to go. We are going to add 3 times a number and the number, and that is going to be less than 8. Okay, if you got it set up right, that's fantastic. Now, did you get it solved right? Let's find out. Combine like terms. Remember, there's the invisible 1 right there, so it's 4n is less than 8. Divide both sides by 4, so n is less than 2. And that's it. That's all you need to do. Just a reminder from the last section, this represents an open circle at 2 and going to the left. It represents negative infinity to 2, parentheses on both sides, in interval notation. And it represents, whoops, it's wrong here. Let me go over this. Okay, because this variable was n, I can't use x down here. I need to use n right there. So I blew that one. So all n values such that n is less than 2. Okay, just a reminder on all of your different possible answers, but all you need is that one. Okay, number 2. Danny's goal is to find a job that provides an income of at least $50,000 a year. The furniture store offers him a job paying a base salary of $17,000 a year plus a commission of 6% of his sales. I'm going to use S for sales this time. Determine what Danny's total sales will need to be for him to have a yearly income of at least $50,000. Okay, let's go ahead and solve this one. Subtract 17,000 from both sides. So we have 0.06s. Make certain your s does not look like your 5. If I make my 5, then my s is fast. That's what they both look like. Not helpful, right? Okay, so make them obviously different. Okay, so then we equals 33,000. Divide both sides by 0.06. Okay, and we end up with s is greater than or equal to a nice whole number. So we don't have to worry about rounding or anything. What does that represent? S, which I said was his salary. Okay, S for salary or sales. Either one, yeah. Two S numbers. I used sales. S for sales. 17,000 represented the base salary. Okay, so it needs a dollar sign. Determine what his total sales will need to be. So he has to have at least $550,000. Okay, number 3. You're planning a reception. The hall you're renting charges a non-refundable fee of $90 cleanup. Okay, in addition to this cleanup, they charge $24 per guest for food and drinks. You have a budget of $3,250. Jeez. Okay, it has to be less than or equal to that. Can't go over, or you would have spent too much. What is the maximum number of guests you can invite without going over your budget? Okay, so now this is one where you have to watch the decimal because you can't have a part of a person, right? So you can't have a decimal representing G for the number of guests. So here we go. Solve this one. We're going to subtract 90 from both sides. So we end up with 24g is less than or equal to 3,160. Divide both sides by 24. And calculator time. So g is less than or equal to 131.6 repeating. Okay, so you can't have 0.66666 of a person. If I rounded that up, I would have 32 people, which would be too much. 32 people would make it go over the original. I have to use 131 people, 131 guests, because 2/3 of a person would make it even. If I do a whole person, it will be too much. Okay, let me show you both of those checks. Okay, so here's the pink part is checking 131, like I told you we needed to use. And then doing all the computation, you get 3,234, which is less than what we wanted. Okay, I'm going to slide it up just a little here. And now I'm going to check 132, because this is what you get if you round the number accurately. Okay, in other words, hang on. If I were to round this, the 6 would round the 1 up, right? So it should be 132 if we're doing the rounding correctly. However, when we actually finish this off over here, we don't get a number that is less than 3,250. Okay, so if you want to quickly do that pink and purple part on your calculator just to double check, that's great. And then that way you know which one's going to work. But if you can logically think through it, you don't have to do any of this part. If you realize that that extra decimal of a person is going to put it over, then you know you've got to round it down to this. Okay, last problem. Elizabeth is trying to qualify for the local bowling championship. To qualify, a person must bowl 5 games and have a combined average score of at least 190. Okay, so at least it can be 190, but higher is better, right? So that's what it's going to, what operation, what inequality, there we go, we're going to use. In the first 4 games, her scores were those 4 things. What is the minimum number or minimum score she must bowl in her 5th game to qualify? Okay, you could just write all of those out. You could go 186 plus 188 plus 173 plus 210, add the 5th game in, and divide by 5. That's kind of a pain to write out, though. So what you could do instead is add all of these 4 together, use your calculator, and you get 757. To me, writing just the 757 add x is totally fine. It doesn't, however, show that you know what averages are. Okay? Averages mean you add 5 numbers, you divide by 5. You add 2 numbers, why are you dividing by 5? So just be aware that you have to divide by how many numbers you add. If the numbers weren't as complicated, if there weren't as many of them, this process would be a lot easier. I'm fine, like I said, if you write this, but try to write it all out unless it totally bugs you. Okay, so times both sides by 5 to get rid of the fraction. Now remember, this is 5 over 1, so we're canceling the 5s, leaving the 1 behind, and we don't need it because it stays in the denominator. It's greater than or equal to 950. Okay, minus 757. So we get x is greater than or equal to 193. So what does this mean? We found that x has to be greater than or equal to this score, and that would make the average of these 5 games, 1, 2, 3, 4, 5, because we're dividing by 5, be greater than or equal to 190, which is what she needs. Okay, these were all under 190, but that one was over. So the average was okay, but not great. She has to bowl 193 in order to make it. Okay, worst possible case scenario on something like this. Let's say, I don't know if you know golf. Golf, yeah, I'm tired. If you know bowling, um, a 300 is a perfect game, I believe. Let's say the answer was 393. Okay, she had to bowl a 393 in order to make the team. She can't because that's physically impossible. Okay, so watch for that, but chances are it won't ever happen. Just be aware that if there is a limit to what this number has to be, make certain it doesn't go over that limit. Okay, like if you're trying to find the average of your own test scores, like the problem we did before, like this one, what if it said your test score had to be a 115? If these are percents, you can't get more than 100% without getting extra credit. So if extra credit wasn't possible, there's no way you could get the grade that you were trying to get. Okay? So it does help you figure out what's possible, what isn't possible. Okay? But in this case, it's totally fine. She needs to bowl a 193 in bowling, not in golf. Alrighty, guys. We'll see you in class.